Hello, my beautiful AP Computer Science students. Welcome to another lesson in Unit 9, Inheritance. This is actually the final lesson in our Inheritance unit, where we are going to talk about the keyword final, the keyword protected, and the Object Superclass. So let's go ahead and get right into it. So the final keyword, this is going to be on the AP exam. We kind of have talked about it before, but it's worth repeating here and just, making sure we got all the bullet points checked off here. So final is basically used to create a constant. You are creating a variable that cannot be modified. You can use the keyword final to method and classes, but in AP CSA, we only talk about variables being final. So you just have to worry about constant variables. You can have constant methods and classes too, but we're not going to go over the ramifications of that. So basically, when a variable is final, when it has that keyword final, you just can't change the value after you create it. You must initialize a final variable when you declare it. You can't. So it has to be, created and given a value. You can't just create and declare it and then assign it a value on another line. It has to be done all on one line. And then obviously once it's created, it can't be modified. And you'll get a compiler error if you try to. So here's an example. It kind of works just like you think it would work. Final double tax equals 0.1, right? So 10% tax. This is how you create it. You put the word final in front of your data type. Any variable can be final. Int, double, float, long, string, boolean, any of those can be final. You use it just like you would use a variable. So here's a correct way to use it. You take 35.50, multiply it by the tax, add it to the original amount, okay, right? So you're getting the tax on the bill. If you try to change it at all, okay, like this right here, tax plus equals 0.05, you'll get a compiler error, okay? You can't give it a new value, increase it, decrease it, anything like that, okay? That's a final variable. Sound good? Look good? Protected. So private members of a class we know can only be accessed from inside the class. And we know public members can be accessed for any other classes. Okay? So when we talk about members, we mean instance variables and methods. Right? So private members can only be accessed from inside the class. So instance variables and methods, when they're private, they can only be used inside the class. Outside the class, you can't call on them and use them. Okay? Public, you can use, anyone can use them, right? If they're public anywhere else can call on them and use them. Protected members, this is new. They can be accessed from other subclasses, but not from any other willy-nilly class. Okay? And that's why we've waited to talk about protected until now, is because it's specifically used with inheritance. Now, this keyword is not covered on the AP exam, but when you're looking at code just online or code from other people, you might see it pop up. So I wanted to talk about it and just give you a quick example of it, okay? But it's not covered on the AP exam. For the AP exam, you just have to know private and public. So this is a good review of those as well. So here is my example, okay? Pokemon. I had a strong Pokemon Go streak way back in the day. I have not opened the app in a very long time, but I digress. So I have a public class Pokemon. I have 3 data types: private int number, public string type, and protected int HP. Okay, and other things are not shown. Okay, we're just going to focus on these 3 instance variables, the 3 visibility modifiers that I have there, and talk about which lines of code can I legally use them and which lines of code would it be illegal to use them. So here I have another class called Pidgey that extends Pokemon. Okay, Pidgey. I call him Pidgey. Pidgey is the name, right? The bird one, right? So Pidgey is going to extend Pokemon. So Pidgey gets number, type, and HP. So Pidgey is going to have those 3 data types. Now, how can it access those 3 data types? Okay, this is where it's going to come in here. So system to out, Pidgey's number is number, type, and HP. So I'm just calling, Pidgey has those three variables, okay? But how do I access that data when I have public, private, and protected? So number is private. Because number is private, this is an illegal line of code. Number is private. When you have private instance variables, you have to use public methods to gain access to them, right? Those were our accessors, right? Like get number. That method, access, it's a public method, and that allows us to access those private variables. Okay? So this is illegal. I can't just say number. I can't use that data type because it's private. Type. Type is public. So this is actually legal. Okay? Pidgey has a type, and when it's public, I don't have to use an accessor method. I can just call on it, and whatever Pidgey was created with the type, whatever type Pidgey was created with, I get to have access to it. Pidgey's hit points are HP. So HP, because HP is protected, this is actually legal. Pidgey extends Pokemon. So any protected variables will be able to be called on with any class that inherits from a super with protected variables. That's kind of a big run-on sentence. But this is a legal line of code. HP is protected, but because Pidgey extends Pokemon where it was protected from, you can use it. Okay. My last class is called Pokemon Go. Okay. Again, I was very good at Pokemon Go for a while there. Okay. I have Pidgey Birdie equals new Pidgey. And then I want to access Pidgey's, or Birdie is my reference. I want to access their data. Okay, so how can I access that data? Birdie.number, birdie.type, birdie.hp. Okay, this looks strange because usually we're dealing with instance variables that are private. We said that from the beginning. You always want instance variables to be private to protect your data. So this looks weird because we haven't been working with code like this because we always protect our data. We always use accessors in order to access this. Number is private, so you can't just say birdie.number and call on it because it's private. Birdie.type, this is legal because type is public. Okay, so you don't need an accessor in order to gain access to it or to modify it even. Okay, birdie.hp, now it's illegal because HP is protected. Okay, so you can't just call on hit points. You have to use an accessor in order to gain access to HP because Pokemon Go does not extend Pokemon. Okay? It does not inherit from Pokemon, and because of that, it's protected. Okay, so that's the difference between the visibility modifiers when working with variables. Again, you just have to know public and private. Protected is not covered on the AP exam. But that's a rundown of what it is. We always like extending our knowledge here, right? We always want to be just so full of knowledge that we're bursting. So there you go. Full of knowledge, you're bursting. The last thing we're going to talk about in this video is our Object Superclass. Okay? And up until now, you might have heard mentions of an Object Superclass, and we've actually kind of overran the superclass before without actually knowing what it is. But the Object Superclass, now that we know inheritance, I can tell you officially all classes in Java extend the object class. Da, da, da. It's always there. It's always been with us. It's always been close. This class, the object class, comes from the java.lang package. And remember that Java automatically imports the lang package, so it's not an import statement you even have to think about. The compiler has always put this extensions there behind the scenes, right? So it's not explicitly put in there, but it actually happens behind the scenes. You can explicitly extend it, and this is what that would look like, but you never need to put it there because it always does it. Right? Extends object. So if you have like the person, student, AP student, the person, whatever's at the top of the hierarchy, extends the object class. So therefore, all objects in that hierarchy are going to extend from the object. Okay. Now, it's because of this implicit extension, we have been able to always have a toString and an equals method on every object we have created. Now, back in Unit 5, we've talked about how we actually want to write our code to overrun these. And now that we know inheritance and polymorphism, we know what overrun actually means. Okay, so we always redefine our toString and our equals method to accommodate the object we are working on. The default implementation up in the object class doesn't necessarily work like we want it to work. Okay, there are many methods to the object class, but these are the only two that are on the AP exam, so this is what we're going to focus on, the toString and the equals method. So the toString method returns a string describing the object. Okay. The default implementation is a memory address. Okay. And you've seen it before if you haven't defined your toString object. It just looks it's weird. It's not useful to us, right? We don't care about the internal memory address of the object we're working with. So that's why we always redefine the toString method. The .equals method, the default implementation checks for reference equality, meaning do the two objects point to the same object, or do these two references point to the same object, which again is not really what we want. We want to use the .equals method to check if they have object equality, meaning are their instance variables equal to each other. That's usually what we want to use the equals method for, and that's why we have a way to override that default implementation. Okay, so overriding toString. This is what it looks like. We've done this before. We have coded toStrings method before, but now we can talk about how it overrides the object class itself. So here I have a class called point, two private instance variables. I have a constructor there, and then I have my toString. Remember, the toString, you can format a toString however you want. It just returns a string. Okay. So here, if I have a point x, y, I want to return it as an ordered pair, x comma y. And that's what I did. So if I create a new point, point A equals new point, system.out.println a.toString, the output would be 3 comma 4 because it runs the toString method in the point class. If I didn't have that there, this would actually still compile and run fine, but it would get that weird class name, point at, and then a weird memory address, which again, we don't really care about. Remember the print line? Also, you can just use the reference variable name, and it will run the toString method as well. So remember, that's actually a feature of this method right here, the print system.out.println. That's a fun feature of that method itself. That's a toString. We've written them before, but again, now we're talking about overriding that object class. Overriding the equals method. It checks to see whether two objects are equal, but again, the way you use it, you want to check if the values themselves are equal, or if the data itself is equal. You don't really care about if they're pointing to the same reference. Okay? But this is the default implementation. So this is actually what's written in the object class that we inherit from. And notice it uses the equal, which checks if they're pointing to the same object. Okay? So the default implementation checks whether two references are equal to the same, or pointing to the same object. So this is the keyword that refers to the calling reference, and OBJ is the past reference. So when I talk about references, the calling reference and the past reference, when we have like this dot equals this, okay? So this is the calling reference, and this is the past reference. Okay, and in this place we put our variables, okay, our reference variables, whatever they are. So we have the calling and the past. Whenever we use the this, keyword, we are referring to this references data, okay, whatever that may be. And then in our method, whatever we call this right here, so in this case it's OBJ, that's referring to our past data. What is past in our data? Okay. So we have calling and past. Equal equal, remember, checks if they're pointing to the same location in memory, but we usually want to override this because we want to check their data value. Okay? And we've done this before. We've written the dot equals method. We've used the this keyword, but we're going to go over it again because we can't go over it enough. So let's say we want to make a dot equals method for our point class. This is what it might look like. Okay, so the dot equals method, in order to properly override our all-knowing superclass, it has to return a Boolean, and it has to be called equals. Okay, and then in parentheses, it accepts one object. Okay, one object. In this case, we're going to accept a point object, and we're going to call it other. And then what I do, I check this dot x equals other dot x, and this dot y equals other dot y. Okay. So this goes back to what we were actually talking about earlier in our with our public, private, and protected example, how we can call on variable names, okay? And specifically how we can call on objects' variable names. So this refers to the calling object, and other refers to the past object. And we're comparing, we want to compare their x's for equality, and we want to compare their y's for equality. X and y were both integers, so we compare them using equal equal. Okay? If this is true and this is true, well then the whole method returns true, saying that yes, those points are equal. So this dot y refers to the calling object's y value. And then the other dot y refers to the past object's y value. And we want to check these for value equality, not memory equality, which is why we're using that equal equal. Okay? If those two y values are equal and those two x values are equal, then you have the same point and you're going to return true. Okay? So depending on your object, our point object only had 2 ints. Your object might have 2 ints and a string. It might have an int, a double, and a string, right? So you have to, in this method, find a way to compare all of those instance variables and return true or false, letting the method know, are all of those instance variables equal or not equal. So here's our last example with point. Point has the dot equals method that we just wrote. Okay, so it has the dot equals method right now. We're not going to be using the references dot equals method, or excuse me, we're not going to be using the super class of objects dot equal method. So I have 3 lines of code. P1 is 5, 3, P2 is 5, 3, and P3 equals P2. Woo. So this is what it looks like in memory. P1 points to the object 5, 3. P2 also points to a 5, 3, and then P3 points to the same thing P2 is, right? So that's our aliasing. And then I have 4 lines of code off to the right here. Okay. If I want to check P1 equal to P2, okay, remember the equal equal says, in terms of reference, because these are object references, for object references, it says, are they pointing to the same location in memory? Okay. For data types, so for ints, for doubles, it asks, are they the same value? Okay. So remember, it's been a while since we've kind of reviewed that, so this would be true. Okay. It doesn't care if there's like a 3 here and a 3 here. It doesn't matter that your references don't point when it comes to those data types. Okay, so just remember that. But here we're asking, does P1 and P2 point to the same thing in memory? It does not, right? Even though they have the same values, they do not point to the same thing in memory. Does P2 and P3 point to the same thing in memory? Yes, it does. that would return true because they point to the same thing in memory. Now when we use our dot equals, okay, in this example, P1 is our calling object. So that would be referring to this. So this dot x and this dot y refers to P1's values. P2 is going to be our past object. So in our example, it was it OBJ? Other. Sorry, other. Other would be our P2. So other.x and other.y refer to P2's data. And because those x's and those y's are the same, this is going to print off true. Okay, which is what you wanted. You want to compare the actual data. And it's going to return true because the data is, the x's are equal and the y's are equal. It even works when you have these two references pointing to the same object. It just compares an object to itself. It's going to return true. Hopefully that's no surprise. Yeah. All right. That wraps it up. We talked about final, protected, and the Object Superclass, kind of, tying off all those loose ends with some of the things that inheritance brings up. So thank you guys for watching this lesson, and I will see you next time.